Okay, so this should be a pretty short presentation. Mean value theorem basically starts out by saying that there's some value or mean value in between 2 points on interval A and B right here that where there is a slope that exists. This originates from Rolle's theorem over here. And Rolle's theorem basically says that when you have a function and you have 2 points A and B on that function where y is the same at both points, there's going to be a point where there's going to be a horizontal tangent line. And from that you can say, at some point C, you get this horizontal line, and then he sort of extrapolates that into, okay, well, at any arbitrary point C between A and B, you can get any tangent line, which is the derivative. Because remember, derivative is the slope of your function. And essentially mean value theorem is this right here. It starts off with the slope where m is equal to change in y over change in x. That's the definition of the slope. And it just sort of transforms into this, the derivative of the function at that central point C over here or here is going to be equal to the function at B minus the function at A over B minus A. This is the mean value theorem right here. It's this whole thing. So when it comes to proving this, I start off with the case x is greater than 0 and f of 0 is equal to 4. So these are the two initial conditions that they want you to use in mean value theorem over here in order to arrive at your answer. So essentially what's going to happen is we're already accounting for this last part of the problem where it says for all x greater than or equal to 0. We're already accounting for that with this initial condition. So what I do, and this is really up to you to put together. I'm simply going to present to you what the tools you need for the proof, and then it's up to you to present it however you will. So we have df over dx, this is the change in the function with respect to x, is less than or equal to 2. So this is the initial condition we're given right here, where the derivative of f is less than or equal to 2. Boom, we have that. And then by using mean value theorem, we equate that with f of, I pick any point above x equals 0, so it could be 1, it could be 1.5, it could be f of 2. I just choose f of 1 to keep it easy, and then minus f of 0 over 1 minus 0, where this is your a and then this is your b under here. So 2 is going to be equal to f of 1 minus 4, so we end up getting f of 1 is equal to 6. Once you get that, we now have another value at another. We just extrapolate another value just by using the mean value theorem for when x is 1. Now what we can also do is we can take this, come down here, and we can bring the dx on multiply both sides by dx. So we get df is less than or equal to 2 dx. And then I integrate both sides with an indefinite integral. And remember, indefinite integrals are integrals where there are no bounds on each of the ends, okay? So when we integrate, we get f of x less than or equal to 2x plus some constant. And this is where we're coming up with the function right here. And we know it's less than or equal to because we're still keeping this in the same form of this original equation. So we're not going to be flipping the sign around. We didn't do anything to warrant flipping the sign around. So now we're getting f of x less than or equal to 2x plus 4 as the main equation. And to get that, we can use this f of 1 value that we got, which is 6, and we can say, okay, 2 times 1 plus c is equal to f of 1 or 6. And I end up getting c is 4. Now, the answer for this will be how you choose to present this, but this should be sufficient, all the sufficient information you need for your presentation. Good luck.